Oliver, as I'm sure you know, is one of the world's best science writers. Used to write for The Economist and be science editor there. And he's just finished a book, which I highly recommend, called Mapping Mars. And Elon has started this amazing new company called Space Explorations and is about to launch a rocket on December 17th or so. And with no more ado, off you go.
I suppose the question we have to start with, given the title of the topic we've been given, is why Mars? Since we're talking about onto Mars, why is it that Mars fires your imagination and has inspired you to start SpaceX?
Well, I should probably clarify the difference between sort of SpaceX, which is really a commercial company oriented at solving a launch problem, and personal ambition in the direction of Mars and what I think we should be doing there. So SpaceX is a company that I formed after PayPal with the principal goal of lowering the cost and improving the reliability of access to space, which, in my opinion, is the fundamental obstacle holding us back from doing more than we're doing today. If we have a cost per pound to orbit of $10,000, there's really not much you can do beyond muck around in low Earth orbit as we're doing today, even with the $15 billion budget that NASA has. On a personal basis, the question of Mars and why that is important, I think, goes to the notion of being a multiplanetary species, or a couple other phrases, back up the biosphere. I think there's a natural tendency for people to extrapolate on a straight line and to think that the way things are today is pretty much the way they will always be, or maybe with a few differences. And I think people fail to appreciate that we're at a very unique point in history. The Earth has been around for somewhere in the order of 4 billion years. Never before now has a species at any time had the ability to expand beyond Earth. This is really the first time in 4 billion years. While it's possible that humanity may see a constant onward and upward trajectory, I think there's also a non-trivial possibility of either an external or perhaps more probably an internal extinction event occurring. And the best way to ensure humanity's survival, and this is just one argument, but the best way to ensure humanity's survival would be to be a multiplanetary species. And the choice of Mars is Mars is really the only possibility, as really you know, and could describe probably as well or better than myself. But Mars holds open the possibility of being another Earth-like environment, and no other place in the solar system does.
Well, the project that you're embarked on, I mean, one of the first things I understand you started thinking of doing was actually moving the first Earth life to Mars in the form of a plant.
Yeah. The way I got into the whole space sector was, I was, as mentioned, just sort of thinking about what to do after PayPal. I was in Silicon Valley at the time, and trying to figure out if there's something I could do to help move the ball forward in space. And probably like a lot of people in the room, my sense of it was that space was really NASA's territory, and there wasn't an opportunity to do anything really entrepreneurial. So I thought, well, perhaps there's something philanthropic that can be done. And the idea was to have a low-cost, high public impact robotic mission to Mars, and something that would excite the American people. And the idea would be you'd get the American people excited, and that would translate to legislative pressure, which would in turn translate to the funding and a mandate for NASA to at least visit Mars, continue what we had intended to do after the Apollo program, and hopefully perhaps establish the goal of a self-sustaining base on Mars. The mission that we came up with was called Mars Oasis, and the idea there was to land a small greenhouse, a small automated greenhouse on the surface of Mars with seeds and dehydrated nutrient gel that upon landing would hydrate and the plants would grow under Martian radiation and gravity conditions.
An atmosphere?
Not a Martian atmosphere. It's a little tricky to do that, but certainly you would get a sense for what it is. What does it take to maintain Earth ambient conditions on the Martian surface? So how do you maintain the right mixture of oxygen and CO2, the right humidity? How difficult is it to maintain the temperature within a certain range given the external environment of Mars? These are all issues you'd have to figure out if you wanted to have a base on Mars, because unless you want to truck all your food from Earth, you've got to figure out how to do it there. So there would be a lot of valuable scientific and engineering knowledge gained from that mission, apart from it being potentially high public impact.
Well, it would be terrific for outreach to schools. That
right,
you can,
absolutely.
That you can have kids planting the same seeds
absolutely.
under Earth conditions and
seeing the difference, and how does a plant grow under 0.4 G versus 1 G. So yeah, we thought that would be a pretty cool mission. And the public tends to respond to precedents and superlatives, and this would be the furthest that life has ever traveled. It would be the first life on Mars. It would be you'd have this very compelling picture of Earth life growing against a Martian background. So I think it would be pretty compelling from a public standpoint, as well as generate a lot of valuable scientific and engineering knowledge. So we did a fairly detailed study of Mars Oasis, and the conclusion was we could do it for somewhere in the order of $15 to $20 million, and that's for everything except the booster. As a basis of comparison, that's about an order of magnitude less than what would typically be considered a low-cost Mars mission in NASA's books. But then we ran into this obstacle of how do we get this to space, and how do we get it out of Earth's gravity well? And the lowest cost U.S. rocket is Boeing's Delta II. And the Delta II, if you are able to strike a very good deal, you might be able to get it for $50 million, more likely 60 or 65 million, which is wasn't really tenable as a price. And that's
4 times your mission.
Yeah,
four times your hardware.
That's a lot of philanthropy. So we went to Russia 3 times to see if we could strike a deal with the Russians for one of their vehicles, and we were able to obtain much lower prices from the Russians, but there were a lot of complications. And when I got back from the 3rd trip to Moscow, I thought, well, why do the Russians have these much lower cost launch vehicles? It doesn't really make sense. Yes, they have a lower labor cost, they have some good engineers and so forth, but Russia tends not to be competitive with the United States in just about any sphere. I mean, we rarely use Russian software. We don't drive their cars, fly their planes, use their kitchen appliances, that sort of thing. Well, who knows? Maybe one day. So there's no reason why they should be able to build a lower cost launch vehicle. So when I got back, I put together a group of engineers that had been involved in all the major launch vehicle developments in the last few decades. So they've been involved with Boeing's Delta 2, 3, and 4, the Titan program, Pegasus, Taurus, all the major launch vehicle developments. And we sat down over a series of Saturdays. Some of these people were still working at the beginning of last year, and just hashed out, well, how do we do it right? On the sort of basis of our cumulative experience, how do we really build something that's a lot less expensive and a lot more reliable? Because one of the things that really has held us back, I came to discover, is that the cost and reliability of launch vehicles has not changed in 3 decades. In those same 3 decades, we've decoded the genome. Computers have improved by 4 or 5 orders of magnitude. Just about everything in technology has improved to some degree, and yet rockets have not. and so we're trying to understand why that was and how we could really make a difference there. And the conclusion after several meetings of that group was that it should be possible to do a much better job. So we concluded in May of last year, started Space Exploration Technologies, or SpaceX for short, in June of last year, and have been working very hard since then. And the vehicle we're building is called the Falcon initially. It's a light to medium class launcher that'll be capable of putting about half a ton to as much as 2 tons into low Earth orbit. And that's our initial vehicle. It's a complete ground-up development. We're developing the engines, the turbopumps, the primary structure, the avionics, the guidance system, our launch operation system, and so there's a lot of things happening in parallel. But we've made a lot of progress. So we've fired our main engine. Our first stage is nearing completion. Our second stage is in production. Most of our avionics are done. We have launch agreements in place with Cape Canaveral and Vandenberg. And if all goes well, we will launch our first customer in December of this year.
Who is the first customer?
It's a U.S. government customer. We'll actually be releasing information on that in probably a month or two. It's actually a pretty significant satellite. It's not really... it's unusual for a satellite of this significance to be on the first launch of a rocket.
Right. I'm sure the project managers are very happy about that.
Yeah.
What I think is interesting about Falcon, though, is that just to look at, in as much to look at the designs, it's a very traditional rocket. It's got a big first stage, a smaller second stage. And a lot of people who've tried, I mean, the idea that what's needed in space exploration is a drastic reduction in launch costs has been around for a long time. And various people have had a go at that. And what they've tended to do is to assume that expendable launch vehicles, rockets with numerous stages, are not the way to go, and that we need a revolutionary technology. We need something that can fly to space in a single stage or just 2 stages, something with wings, something completely reusable. And it seems to me that you're saying, no, we can do it just with a tried and tested concept, just by doing it better and by avoiding having the overhead of working for the world's largest defense contractors.
Yeah, I think a lot of that is true. I mean, one thing that is notable about our vehicle, though, is that although it appears, I mean, it appears like a regular vehicle, but there are actually a lot of things different about it. You know, one thing that is notably different is that we do recover our first stage. And it's a very simple recovery process. We simply allow the first stage comes in by itself without any help.
Parachutes?
Yes, parachute. And it has enough drag to slow itself down to subsonic velocity. And then when it's going about 300 miles an hour, we toss out a drogue parachute and then a main parachute reaped in 3 stages. And it lands in the water actually quite gently. And then we just have a commercial salvage operator go and pick it up for not much money at all. And you know, simple as that sounds, that's never done with conventional launch vehicles, which seems a bit crazy. Now we have taken steps in Falcon to ensure that it is marine water tolerant.
I was going to say, dropping a hot rocket nozzle in the sea must be quite difficult.
Well, exactly. So for example, our nozzle, the one part of the first stage that is thrown away each time is the nozzle.
Right.
It's sort of like you can think of it like the brake liner in a car. And because it hits nozzle first, you want that to be a disposable part.
Right.
So we designed it to be that way. And so it's actually very cheap and disposable. All the expensive engine stuff is above it. And there are things you have to do to minimize galvanic potentials, have a sacrificial anode, coat it with allodyne so it doesn't corrode. And provided those things are done at the design stage, they're relatively easy to do. It would be much harder to retrofit one of the existing rockets.
There are a lot of other people there's a number of other people taking computer-generated money into the space business at the moment. Jeff Bezos, and there's someone we do not know whom, bankrolling Bert Rutan. What's different about your approach to those approaches, which are largely predicated on winning the X Prize, which is a cash prize put up by a foundation dedicated to these sort of things for reusable spacecraft?
Right. Well, there's sort of a pretty substantial difference between what we're doing and the X Prize vehicles. The X Prize vehicles are suborbital. And the complexity of a suborbital vehicle is actually much less than that of an orbital vehicle. It's probably an order of magnitude difference. The kinetic energy you need to get to the X Prize parameters, which is 100 kilometers, and it's just 100 kilometers up with no horizontal velocity. You need to get to about Mach 4 to do that, which is relatively easy. And the kinetic energy scales as the square of the velocity, so that would be, say, 16 units of kinetic energy. But to get to orbital velocity, you need to get to Mach 25, and the square of that is 625 units of energy. So you sort of have 16 units of energy versus 625 units of energy. It's really a huge difference in difficulty.
So you think the suborbital approach is, to some extent, a red herring? It's a distraction?
The X Prize is intentionally set to be suborbital in order to make it achievable and to make the prize worthwhile. The prize is $10 million. And it's not clear that, well, at least most of the teams are not sure they can actually develop a suborbital vehicle for $10 million. So the parameters of the X Prize were set to be sort of achievable without necessarily being Boeing or Lockheed.
Or indeed achievable without necessarily being useful.
Yeah, I mean, it's not useful in the context, it's not directly useful in the context of actually leaving Earth. In order to leave Earth, you must reach orbital velocity. And the suborbital, you go up and you come down, definitely. And interesting.
Orbital, you go up and you hope you can come back down.
Orbital, you go up and you stay up unless you
choose.
Unless you do something to come down, yeah. And actually, the interesting thing about escaping from Earth, and this is not obvious to anyone who hasn't studied astrodynamics, is that your vertical velocity doesn't mean anything. It's all horizontal velocity. You sort of think, well, if you go to space, you kind of go up, but actually you go parallel to the Earth, and you kind of spin out like you're in a giant salad bowl, and you want to.
I'm sure lots of people see at school little pictures in physics books with a big mountain with a cannonball coming off it, but they don't actually internalize the fact that the cannonball goes off, it doesn't go up.
Right, exactly. Yeah.
So if the idea is to leave the Earth, Falcon is obviously a first step. I mean, if you say you're getting 1/2 to 2 tons to low Earth orbit, how do you intend to scale up the Falcon technology? Yeah, absolutely. Falcon is really a scale model for our later efforts. And what we'd like to do is to build a very large first stage, and then use the 2 stages of Falcon as the second and third stages for a very large vehicle. And the long-term sort of holy grail of SpaceX, if everything works out, and that's a big if, would be to build Saturn VI, the successor to the Apollo moon rocket. But do it in a way that's much less expensive. And also in a way that generates revenues along the way. Yeah, exactly. And what are the cost differentials between a Falcon launch and a launch on a current commercial competitor? Well, the nearest U.S. commercial competitor is Pegasus, which is made by Orbital Sciences. There are really just 3 launch vehicle companies in America: Boeing, Lockheed, and Orbital Sciences. And Orbital Sciences produces a couple of light to medium rockets, and then Boeing and Lockheed produce heavy lift rockets. So Falcon, as compared to the Pegasus has a NASA list price of $30 million and a failure rate of 10%. A Falcon, the Falcon is priced at $6 million. So it's about an 80% discount over our nearest U.S. competitor. Yeah, and in fact, what we're targeting is not so much our U.S. competitor as the Russian options, the Chinese options, and they're also
smaller satellites that will go as piggybacks
Right.
on the really big rockets. So it sounds like, well, perhaps we're pricing it sort of too low, but that's really our competition. It's not so much Pegasus, but it does.
Because no one commercial uses Pegasus, do they?
It's rare. It's very rare. It's mostly U.S. government use, so Falcon will be $6 million, and it actually has a lot more capability than Pegasus. Pegasus can only put less than half a ton, about 400 kilograms.
It's more like the Taurus sort of range.
Yeah, Taurus does more. Although Taurus has a $50 million price tag. That's the NASA list price. So, if Falcon is successful, in assuming that it has a reasonably good reliability track record, it will be quite disruptive to the U.S. aerospace sector.
And in the long run, presumably, certainly when you get up to Saturn VI levels, you want to be sending people up there as well. Would you be... I presume you wouldn't be trying to develop a space plane or anything as costly and somewhat highfalutin as that. Would this be straightforward use of capsules, as God and John Glenn intended?
Yeah. The long-term goal of SpaceX is definitely human transportation. We want to prove ourselves out with satellites along the way. But when we do come to crew transportation, there's obviously a need to... most people want to make a return trip. In terms of getting back to Earth, a capsule, I think, makes by far the most sense. A capsule will to be exact, a propulsive lander, I think, makes the most sense. So I think if we were to get to that point, the approach that we would take would be a ballistic re-entry capsule, essentially, so that you're not dependent upon a very tight angle of attack, as you are with any winged vehicle. And then use a propulsive landing system so that you could essentially land on something as small as a helipad. And it's not a particularly outrageous approach. Certainly the Apollo lander on the moon took that approach. And there was a project called DCX, which some people here may be familiar with, that also was a propulsive vertical takeoff, vertical landing system. And the advantage of a system like that is it doesn't just apply to Earth.
Right.
If you build a winged vehicle, you're going to make that winged vehicle work for Earth. And that means that's the only place you can go to and from. Whereas a propulsive lander, you could go to the moon.
Anywhere your fuel will take you.
Yeah, exactly. It's independent of the local environment.
So what's the timeline? When would you imagine? I mean, you're talking about a first launch this December, if all goes well. When would you think you'll first be launching the two dates? And when would you first think you'd be launching the upgraded, enlarged Falcon that would be Delta class? And when do you think you might first be launching a person?
Well, there is an enlarged version of, just to clarify, there's the small version of Falcon, which does half ton. There's the enlarged version of Falcon, which does 2 tons, and then there's the follow-on vehicle, which would be...
I was thinking of the follow-on.
Yeah, the follow-on vehicle. We have a code name for that right now, which is BFR. If anyone has played Quake, they'll know what I'm talking about. And that would be probably, that's really dependent upon how long it takes us to develop the big engine, the BFE. That's probably a 3 or 4 year process, because developing an engine on that scale is really, really difficult.
Right, it's not just using multiples of your existing engine.
Right, exactly. And there are scaling issues in rocket engines. You get combustion instability at large thrust levels, which generates this enormous shriek before the engine blows up.
That's fun.
That's the problem that they had with the development of the F1 engine. For the Saturn V.
Right.
So I would say probably a 3 to 4 year development horizon.
But the BFE would be on the same sort of scale as a shuttle main engine or a Saturn V F1, or one stage down from that?
It would be bigger than an F1.
Wow.
Yeah. assuming we can build it, it would be the biggest engine of any kind ever built.
Okay. And
Big if. Yeah.
but and in the long run, how far do you see yourself personally going? Do you want to go to orbit yourself?
I don't know. I mean, I think certainly if it was safe enough, you know. It's that question for Marathon Man, is it safe? If it was safe enough, sure.
But to some extent, it's more the idea of opening up space to humanity that drives you rather more than the idea of personally.
Right, yeah, absolutely. This is really about seeing if we can do some good for human expansion beyond Earth, as opposed to a personal desire to go to space. I mean, I never grew up wanting to be an astronaut or anything like that.
Right.
So no, this is more because I think it's really, really important that we expand beyond Earth. Because I think there's nothing more that would more powerfully assure humanity's future, assuming that one thinks humanity should have a future.
I suppose that answers my other question, which is why do this rather than a third Silicon Valley startup?
If by Silicon Valley startup you mean like an internet or networking or something like that. This was the most interesting thing that I could think of, and it probably uses the two skills that I have, which is technology and entrepreneurship, and it doesn't happen to be in Silicon Valley. I actually moved down to LA to do it because LA is the biggest concentration.
Aerospace people are.
Exactly, it's the biggest concentration of aerospace talent in the world, and I think being where the talent is the most important location for a business. But it is, there are some similarities. I mean, this is a technology startup. So.
Okay, well, I think we've probably got. Have we got time for a couple of questions? Please.
Scott Scharfman. The question is, you're talking about roughly a 75% decrease in launch costs to orbit. What effect does that have on customers? Do you think you'll generate new kinds of users of satellite systems?
Yeah, I think so. And there's some evidence for that already because we have 2 confirmed customers at this point, and at least one of them would not have flown were it not for Falcon. They simply did not have the budget to do it. So I do think we will open up a market. It's not clear how big it will be, but I think I would say there's definitely some market expansion that occurs. One area in particular, as applies to Falcon, is university and research satellites. There are a lot of university engineering graduate programs that have the wherewithal to put together a satellite, and by virtue of relatively free labor and donated parts and so forth, can build a satellite that is worth several $1 million. But they can't afford to go and spend then $30 million on a Pegasus to get it to space. There needs to be kind of a cost impedance match between the satellite and the launch vehicle. And I think having Falcon there, priced at a level which is comparable to the cost of the satellite, could open up a significant market in that area.
Thanks.